Hello and welcome to the first video in our series about the Open Digital Architecture Canvas. In this series, you'll hear from me and other members of the ODA team as we explore the work being done to build an ODA Canvas and a reference implementation. This video is targeted at two groups. Firstly, it's targeted at architects or software engineers building functional software components. We'll explore what it means to develop software components that meet the ODA standards and how to use the ODA Canvas as an execution environment. The video is also designed for architects, software engineers, and site reliability engineers who are building or operating a Canvas platform. Whether you're working for a communication service provider building your own ODA Canvas, or for a hyperscale cloud company delivering a managed platform for others, this video is for you. I'll start by giving a high-level overview of where we are today, starting with a bit of a history about how we got here. Then we'll cover what exactly an ODA component is and what the ODA Canvas represents. And we'll also dive into the business benefits of adopting the component approach, why it matters and how it compares to traditional methods of deploying and operating software. Finally, I'll provide an overview of some of the modules of the ODA Canvas that we've already developed. Think of this as a preview. In upcoming videos, we'll take a deeper dive into each one of these modules alongside the contributors who help bring them to life. Thanks for joining us on this journey. We hope you find these insights valuable. So let's get started. Over the past 25 years, the TM Forum has been a hub for collaboration, driving frameworks and standards that accelerate the evolution of telecom IT capabilities. In the early days, we started with foundational frameworks that provided a common language covering process, information, and functional areas. These frameworks were very valuable, offering insights for tasks like product selection or defining change scope or supplier evaluation, but they were human-readable artifacts, open to interpretation and implementation variation. So this led to each operator, including Vodafone, developing custom variants of these standards, resulting in inconsistencies across the industry. The next significant step was the launch of TM Forum's Open API initiative. Around 2013, we began experimental work with APIs, conducting hackathons and other events, and in January 2017, we officially launched the Open API initiative. These detailed, prescriptive, machine-readable specifications define standard-based services that could be used on top of IT systems. This initiative gained wide adoption across the industry, with over 900,000 downloads to date by over 50,000 individual developers. And every IT capability we build in Vodafone starts with the question, what APIs do we need, and how can we leverage the standard APIs we already have? And since then, the Open API standards have continually evolved, with a strong community constantly improving the standards and helping adoption. However, even with these standard APIs, there are still considerable challenges when it comes to deploying and managing IT software. Telco IT environments are diverse and very complex, with hard-to-maintain systems, and we find it very difficult to upgrade and continuously improve our systems. Often upgrades require complex transformation projects, upgrading multiple different systems at the same time. And to tackle this, we created the idea of ODA components. So ODA components are independently deployable units of functionality, modules that clearly define not only their functional capabilities, but also their non-functional requirements, such as security, observability, and management. The ODA component standards ensure these components are interoperable, designed for end-to-end use cases, and importantly, they're portable, meaning they can be deployed on any standard Canvas platform. And that's where the ODA Canvas comes in. The ODA Canvas is a software-defined blueprint for a cloud-native operating environment that serves as the execution platform for ODA components. It provides the underlying services to these components, covering everything from API management to observability, which means the component developers can focus on functionality while the canvas takes care of operational concerns like security, monitoring, and scaling. And in today's discussion, we'll go deeper into these two parts of the story, the modular ODA components and the ODA Canvas. So the components represent the modular building blocks that form our IT architecture. Teams have worked tirelessly to break down the end-to-end telecom processes into these modular components, identifying data, functional capabilities, and how each component fits into the overall value chain. And this brings to us the idea of composable IT. As new business challenges emerge, we should be able to rapidly assemble existing components to meet those challenges. These components are intentionally designed to work together, promoting a composable approach that is essential in today's ecosystem-driven business environment, where integration across ecosystems is the norm. The ODA Canvas addresses the non-functional needs of components. Whether it's security via standardized identity management systems, observability through metrics or traceability, or event-based API management, the Canvas standardizes and simplifies these aspects so components don't need to reinvent the wheel each time. For example, with identity management, instead of each software component have its own system for identity management, the Canvas provides a unified identity management service. And the components can describe their requirements, so it can describe what roles or permissions they need to be created in that identity management platform. And this is crucial for telcos like Vodafone, where a consistent approach to managing user identities across multiple applications will dramatically reduce complexity and cost. The security part of the canvas also provides a secrets vault that components can use to store passwords, tokens, or other sensitive data in a secure way. And we're also working on some emerging services within the canvas, such as AI management or cost management. For AI, we envisage components can declare their requirements for AI services, whether it's access to foundational AI models or hosting custom AI capabilities. And this opens up the possibilities for smarter, more intelligent components. And we imagine most components over time will be using AI systems as part of their core capability. Similarly, cost management will enable transparency and automation around software usage and licensing. And the carbon management is about our sustainability. So it's how do we embed the ability for components to be able to make smart decisions about how they're using compute. For example, allowing components to intelligently shift workloads in time or in location to optimize for green energy usage. So what are the benefits of these approaches? Why are we doing this work? So there's lots of benefits, and we believe this is a win-win situation for CSPs, for software vendors, for system integrators, for cloud providers. We think there's a win-win, and this could benefit the whole industry in terms of our agility and an ability to build cloud-native software solutions. So there's customer experience benefits through seamless integration and zero touch, zero weight, and zero trouble operations. I've already talked about the simplicity benefits. So we're going to move from hundreds of operations teams managing vertically integrated applications to our target is to have a single site reliability engineering team managing the Canvas platform with components and a huge amount of automation in terms of how those components are deployed and managed. We believe this will unlock innovation through agility and the accelerated adoption of new technology opportunities, for example, around the AI native services that I mentioned earlier. And our goal is for this to help drive industry growth. We believe this will give us operational efficiency and agility through automation. So our goal is that integration of telco software moves from being a manual project to being a fully automated implementation. We've built security at the heart of this, so the core architecture implements zero trust, and we've adopted this concept of security as code, and also the reduced variance and greater collaboration on risk management will improve the security footprint overall. And finally, for technical debt, so we believe this will help us move from today, where we have lots of systems which aren't continuously upgraded, to a position where we will continuously upgrade every single software component in our software systems, because we have these decoupled and modular interface contracts. Overall, we believe this could give us a 10 times efficiency and agility improvement. So we're not doing this for a 30% improvement in our agility and efficiency. We believe this can give us a step change, an order of magnitude improvement in efficiency and agility, and also to accelerate the transformation to an AI native telco. So what is in the ODA Canvas? So the Canvas itself is a modular platform, and the team developing the Canvas, we work on these three different horizons. So the horizon one is focused on the here and now. So what can we do to improve the experience of people deploying and adopting the reference implementation of the Canvas? So we've done a lot of work to improve how easy it is to install the Canvas. So the Canvas at the moment is just a set of Helm charts that you can go and deploy on any Kubernetes platform. And we've tested across all the major Kubernetes cloud platforms. There's been a lot of work on how do we improve the security and automation on how we're building the images in the Canvas. So now, if you're part of the team contributing to the Canvas in the GitHub repository, all the images are built automatically, and they're put into a TM4 Docker repository, and we're improving the security hardening of those images. Similarly, we've done a lot of work on test and release automation. So when you're contributing a change into the Canvas is defined through tests. We're using something called BDD, or behavior-driven design, to actually define what the Canvas is in a way which is testable, and then supporting that, we then have a full suite of tests. And whenever anyone does a contribution to the Canvas, as part of the pull request process, we run this full suite. So we actually deploy their proposed Canvas onto a Kubernetes cluster and run a full suite of automated tests, so that we know before we accept any contributions, we know that it doesn't break anything, and also anything new has to be defined or described using these tests. And finally, we have an Innovation Hub dashboard, so the team contributing to this, we have a very nice dashboard showing all the work we're doing and tracking our progress at delivering against the different ideas and issues that we have. This is all about the actual features of the Canvas, or developing new features. So I mentioned that when you have a Canvas, it manages API management for you. So I'm just going to dip into this a little bit. So the concept is a component can describe its requirements for what APIs it wants to expose to outside of the component. And these could be part of its core function, or they could be part of its own security and management. And when you describe your requirements for APIs, what happens is the component has this declarative definition of its requirements. So it's a machine readable description of its requirements. And the Canvas platform can use any API gateway or service mesh to expose these APIs in a secure and controlled way. So we're not choosing a particular set of technologies, we're just describing a standard way in which you can articulate your requirements in a declarative model, and then API operators in the Canvas automate the configuration of those API gateways and service meshes. So you can think about this API operator. It's a bit like having a human operator could take a requirements document from a component and then go and manually configure an API gateway. So returning that and adopting a pattern of actually having software operators. So these are software operators, bits of software that run as part of the Canvas. When you deploy a component, they will look at the requirements for, in this case, API management, and then they will go and automatically configure whichever API gateway you've chosen to use in your Canvas implementation. And to date, we have 6 different options for API management. So the core team, we developed API management using 2 open source gateways, so Apache API 6 and the Kong API gateway, and also for using just Istio Service Mesh, so Istio Service Mesh without an API gateway. And then Google, Microsoft, and Whale Cloud each independently developed API operators for their own cloud platforms. And this is just showing like the model we've got. It's a modular model, but it's also extensible. So any API gateway that can be automatically configured through APIs, you could build an operator for that API gateway. And our goal is to have operators available for every common API gateway platform that any CSP would want to use as part of their operations. And this is a model for how the canvas works. So a declarative description of your requirements, and then these operators which can actually take those requirements and automate the deployment and ongoing management of that piece of software. So in the Horizon 2, we've worked on API management. We have secrets management, which is about how do you have like a secrets vault where a component can ask to store passwords or other sensitive data that they want to be stored in a secure way. There is a Canvas portal and a set of tools around how do you interact with the canvas. There's work on identity management, and in a similar model, when you look at the identity management, the component describes its requirements for roles and permissions. So a component doesn't master identities. We're moving that to master identities in a Canvas identity management platform, but you could use any identity management platform. The component describes its requirements, which is basically saying, these are the roles and permissions I know about, and I want these to be available for you to attach to identities in your identity management platform. And then when you actually have an implementation of a canvas, you have an identity management operator, or identity config operator we've called it, that can automate the configuration of that identity management system. And at the moment we have 2. We have one based on Keycloak, which is an open source identity management solution, and Microsoft have built one for their Entra ID identity management system. And then in our new features, the final one is we have features around observability management. So again, we have different options for a component will expose metrics and telemetry data using open metrics and open telemetry. And then you can choose what service you have in your canvas to actually get access to that observability data. And we've developed in the core team, we developed some ones using open source, using Prometheus, Grafana, and Kiali. And then both Google and Microsoft have developed versions onto their managed observability services in their cloud platform. And we've also developed one on top of Datadog to actually show that you could use Datadog for observability and getting observability data from the components. And it's interesting to note that when we're showing this observability data, it's not just the technical observability from a component. You can also include business observability. So you can actually create business events. So for example, if we've got a product catalog, every time someone creates a new product or a new category, you can have that as a business event going into your observability. And that's what we're working on in terms of the Horizon 2, which is like the new features we believe we need to have for launch of the ODA Canvas. But the team's also working on experimental services. So we believe that in a short period of time, virtually every software component will be using AI services. And we're setting out to have a standard way that they can describe their requirements for AI services. And this could be for custom AI models, or it could be to access foundational Gen AI models. And it could be the associated vector databases or retrieval augmented generation frameworks, which will help a component actually implement some AI service. And we've been experimenting with what do we need to do in a canvas to make those services of the cloud platform available in a standard way, and also from a component, how you describe your requirements for AI services as part of the component definition. In the experimental space, we've also got work on the developer experience. So how do we actually improve the experience of developers developing components into the canvas, or of developers developing new operators into the canvas? And we think it's really important that we actually focus on their experience and how do we attract them to develop components in this standard way. And as I mentioned earlier, there are some other operators focused on things like carbon management. We've done a little bit of work in this space around how do we monitor and get data about the carbon usage of components. But what our intention is, there will be a suite of services in the canvas to make components able to make smart decisions around carbon usage, around cost management. And we're also going to do some work around having access to standard databases as part of a Canvas service. So this is the set of services that we're having as part of the Canvas. It has been the result of extensive collaboration across communication service providers, hyperscalers, software vendors, systems integrators. It represents a collective contribution to what we originally set out in our ODA manifesto for a standard execution environment for ODA components. We believe the ODA Canvas will accelerate the adoption of this ODA component model, and it'll also provide the foundation for how telco software can evolve at a greater speed going forward. I mentioned the AI management operator, so we believe that by collaborating in this way, we can make AI services available to every piece of software in a much faster way. We can accelerate the adoption of AI services across all of our software components in a much quicker way through having this force multiplier of collaboration. This video is just a teaser. As I said, we're going to create future videos and we're going to get each of the collaborators that have contributed to this initiative to develop videos into their own areas where they built their collaboration. So please look out for future videos, and these will go in depth into each of the areas I've touched on today. Also, if you have any comments or you'd like to contribute to the project, then please engage with us. I'll put links in the footnotes of the video. Okay, thank you very much.